In this quick tutorial, we'll show you how to perform a one-sample t-test in SPSS and how to interpret the results. One-sample t-tests are used to determine whether the mean of a single sample is significantly different from a known or hypothesized population mean. In this video, we're going to use data from a hypothetical study looking at how long it takes people to fall asleep in a statistics class. Imagine that we already know that in the general population, the average time it takes someone to fall asleep is 8.45 minutes. We want to know whether the time it takes people to fall asleep in a statistics class differs from the time it takes the general population to fall asleep. To do that, we're going to use a one-sample t-test. To perform this test in SPSS, we click Analyze, then select Compare Means and Proportions, and then One Sample t-test. This opens the One Sample t-test dialog box you see on screen. First, we need to move the variable we want to test against the population to the Test Variables box on the right. In our case, this is time elapsed before sleep. Next, we enter the population mean in the test value box. In our example, the average time it takes the general population to fall asleep is 8.45 minutes. Estimate effect sizes is checked by default. We're going to leave it like that. Now we're ready to perform the test. Once we click OK, the test results will appear in the SPSS output viewer. Our output includes three tables. First, in the one sample statistics table, we see that the mean time to fall asleep in a statistics class is 7.35 minutes. That's less than the population average of 8.45 minutes. But to determine whether this difference is statistically significant, we need to look at the one sample test table. The t-value is -4.691 and the significance value or two-sided p-value is less than 0.001. Since less than 0.001 is less than the standard alpha levels of 0.05 and 0.01, the difference between the time it took people to fall asleep in a statistics class and the time it took the general population to fall asleep is very unlikely to have happened by chance. Just as a reminder, a p-value that is less than or equal to our alpha level means the result is significant. However, a p-value that is greater than our alpha level means the result is not statistically significant. In other words, the results of our hypothetical study indicate that people fall asleep faster in a statistics class than in the general population. Finally, let's review the one sample effect sizes table. This table gives us Cohen's d, a measure of effect size. In other words, it tells us how big the difference between the groups is. We want to look at the value under point estimate. In our example, Cohen's d is -0.469. This would generally be considered a small to medium effect size based on the conventional benchmarks. These are based on the absolute value of d, that is how far it is from zero, regardless of whether it's positive or negative. So in this case, we can say that there is a small to medium difference in how long it takes people to fall asleep in a statistics class compared to the general population. Thanks for watching. If you found this video helpful, don't forget to subscribe for more simple SPSS tutorials.